Our default position is to think about amber roads and red roads. And little thoughts ever given to green roads. Of course, green roads are the amber roads of tomorrow. So really my presentation is trying to just get us focused on what we can do to keep green roads in good condition and to hold the network condition for longer. The context really is that the road network is a council's most valuable asset. Extending the service life and maintaining it in good condition helps to deliver many of the council's key objectives. And coming very much from the asphalt industry, I spent 13 years at Tarmac. We are aware that asphalt ages pretty much from the day one really. Why is that? Because the glue that holds it together, the binder, is called bitumen, and it ages. It hardens, it becomes brittle, and it starts to crack. And eventually it'll lose its integrity and the asphalt will start to develop cracks, which become bigger cracks, which become potholes. So asphalt preservation really is recognising that road surfaces, asphalt road surfaces, actually have defects in them at a much earlier stage than we are normally aware of. So the choice really from an engineer's point of view or a maintenance programme point of view is, do you sit back and wait for these defects to become visibly apparent and then intervene and deal with them, or do we accept and recognise that the defects are there, albeit in sort of invisible micro form that can be treated earlier, and in doing so then keep the road surface in good condition. The binder that we use penetrates the road surface. Anybody got any idea how far it penetrates in? 2 millimetres? 5 millimetres? If I said 30 millimetres, what would you say? Rubbish! When I joined ASI back in January, one of the first things I wanted to understand was, where does the binder actually go? And we'd recently done some work, got a slide later on at a couple of universities that demonstrate the binder finds its way into all the microcracks, all the interconnecting air voids, and penetrates between 20 and 30 millimetres into the surface and seals it. And it can treat any form of asphalt. It's probably, in my opinion, more effective on SMAs and asphaltic concretes, simply because HRA will be denser, more durable anyway, but it can be used on HRA as well. And it will seal all those microcracks. That slide there just tries to illustrate what the microcracks will look like. And the binder is very hard. If you're into your bitumens and your asphalts, the binder is typically 2 pen. So it's a very, very hard binder, and in penetrating it will also toughen the surface and improve the abrasion resistance, or wear resistance. So the main outcomes are it extends the life of the carriageway surfacing. We recommend treating every 5 years. That's because over a 5-year period more microcracks will form under trafficking. Helps to reduce whole life costs and will help to improve and maintain your network condition. Just to try and put in some sort of context, this is what most authorities do today, the conventional life cycle planning approach. We're sort of managing deterioration. In this example here, we've shown that we'd treat or we'd start patching the surface around about year 10, depends what the surfacing is. What do you get for your SMAs in Scotland? What sort of service life do you get? Get 15 years? That wasn't meant to be a joke. So here you basically patch and repair at, say, year 10. You then do some surface dressing, and you can see the general trend appearing there. So the road condition is going from being excellent to good, and beyond year 12, we're starting to slip into average to poor condition. With preservation, it's all about keeping the road surface in good to average condition for much longer, treating every 5 years. So what's the process? It is seasonal. We recommend April through to September. Having said that, one of our delivery partners treated the A6 at Rushden a couple of weeks ago in October. Did 24,000 square metres in a shift. But the surface needs to be dry, so providing it's dry, you can apply the product. The application rate is about 0.5 litres per square metre, so typically about 25% of the application rate that you'd use in a surface dressing. It's applied using a combi sprayer. So it's a fairly conventional combi spray that's been slightly modified because the process is a two-stage process. We apply a binder and instantaneously apply grit, a very fine grit afterwards. It's very fast. We treated up to 30,000 square metres in a shift. May sound impressive, but the reality of delivering that in an urban environment at night time can be tricky with lots of junctions and roundabouts. It can be applied during the day or the night time, and I think it's the only surface treatment I'm aware of that can be applied at night time, providing it's above 5 degrees and it's dry. Rapid drying time between 30 minutes and 2 hours, and during that closure you can do the road marking and fill any serious longitudinal cracks. And there's no aftercare, it's one site visit, 3-man operation, no remedials. As with any fresh surfacing, you will see some reduction in your scrim. We typically see about 8% reduction or drop in scrim value immediately post-application, so we'd not recommend treating any road that's near its investigatory level. The grit that we apply is typically 0.5 to 1 millimetre diameter. It's aluminium silicate, very hard material, and that helps to remove the binder off the coarse aggregate to restore the micro texture and bring the scrim back into play. The scrim recovers fairly quickly. On the M40, for example, we've been treating the M40 since about 2003. The scrim comes back within a matter of days because of the level of traffic. So it's very much traffic related. And on a local road, probably a couple of weeks. So it's suitable for treating strategic, resilient and urban routes, but also for treating lightly trafficked urban roads, cul-de-sacs, estate roads, difficult sites where other treatments may struggle, roundabouts, for example, tunnels, and also treating utility trenches. The well-managed highway infrastructure code of practice that came out last October, a number of recommendations in that document are aligned with using preservation. Things like reducing whole life cost, maintaining a resilient network, keeping those important routes open at all times during the winter, life cycle planning, and obviously reducing your carbon footprint. On carbon footprint, preservation is about 92% reduction compared to resurfacing. You're applying very little material to the road surface. There's minimal environmental impact in adopting this approach. And highway authorities are being encouraged to innovate and try new things, and again, preservation fits into that sort of category. We've got a HAPAS certificate for our product. The specification clause is 950. It doesn't say very much actually, it's a very minimal spec. It just calls up some form of product certification. So we've actually developed a 2-page technical specification to assist authorities in specifying the process. And we'd obviously recommend that contractors and authorities using it adopt the RSGA guidance document on preservation, which I believe has recently been endorsed by ADEPT. Contractors should be registered to Sector Scheme 13. A number of product requirements there regarding cure time being around about 2 hours, applying seasonally between April and September. And on page 2, we talk about surface preparation, making sure the road's been swept adequately, any street furniture has been masked, checking that the investigatory levels are not too low. In terms of testing, we prefer to use hydraulic conductivity testing, which basically means that you're going to get no water penetrating through the surface. Check your scrim value and check your texture. On surface texture, there's no impact on surface texture. On-site testing, we did some work on the M4, that was treated with RHiNOPHALT a few years ago, 2014. It was tested in 2018, 4 years post-treatment. The treated sections on the conductivity testing, basically the test was stopped after 10 minutes because no water was flowing through. On the untreated section, the water flowed through in 3 minutes. So it just demonstrates that you are sealing the surface, keeping water out, and other nasty materials like salt grit, for example, that can cause durability issues. The A50 is an interesting case study. This was an SMA that was 10 years old back in 2008. Connect Roads managed the A50 and they were wondering what to do next really. They heard about our product, they thought we'll give it a go, might get 2 years out of it. That was 2008. By 2013 it was still in pretty good nick, so they used it again. And in 2018 it was still in pretty good condition, so they used it again. So the SMA there is now 20 years old. And as you saw there, they are seeing 65% reduction in reactive maintenance. But I was intrigued by this. It was the first publication really where Highways England had put their name to the paper The results showed the benefits from preservative treatments in maintaining the properties of material underneath the treated surface, and they show that the application of preservative has the potential to keep the pavement surface in the condition it's in at the time of application. And the use of preservatives provides a protective seal on the pavement surface that can slow down the ageing process. We did some work at Nottingham University quite recently. The picture on the left, it's an SMA core, and the hazy blue represents the void structure in the SMA. They used X-ray CT scanning technology to three-dimensionally model the void structure in the core. Then we applied RHiNOPHALT at the application rate 0.5 onto the surface. That's what the yellow represents, and you can see that it penetrated in over 30 millimetres. Quite remarkable. The picture on the right there, shows the reduction in porosity, the reduction in voids. So essentially going down from 10% air voids near the surface down to sort of 5% air voids with depth. And as we know, once you get down to 5 or 6% air voids, the ageing process is severely reduced. So just to wrap up, in terms of benefits, it reduces demand for reactive maintenance. You're going to see far fewer potholes and less claims. Provides an alternative to surface dressing on sites where this isn't a preferred option. It can double the asphalt surface life for half the cost compared to resurfacing. That's treating every 5 years. It helps with life cycle planning. It provides invisible working, can be applied at night time. High productivity, up to 30,000 in a shift, square metres in a shift. One site visit, no aftercare, no post-sweeping, no remedials. Provides good road availability. It breaks the deterioration cycle. It'll hold your network condition, keeping green roads in green condition for longer. Good carbon savings, good aesthetics. The public, who are voters, will like what they see. Operationally, there's no ironwork lifting. It maintains existing curb heights. No additional weight applied to structures such as bridges. The existing road surface profile and surface condition is maintained. So in an urban context where you've got SMA, which provides a nice low noise value, it'll maintain that, which is important. We're not using a high PSV aggregate, so it reduces demand for that. It's friendly towards utility trenching. It's proven technology, easy to apply. It doesn't prevent other treatments from being used. This process is aimed really at the early stage in your life cycle planning. Typically 2 years before you know you're going to get into reactive maintenance. So if you get, say, 7 or 8 years out of your SMAs, for example, you'd be looking at using this in year 5 or year 6, 2 years before you know you're going to start to see cracks and potholes appearing. So in summary, it delivers outcomes, extends the life, reduces your costs, improves the road condition, provides good aesthetics, it's fast, one visit, environmentally beneficial, and it's very flexible. It can be used on local roads, your strategic network, and also special treatment areas such as roundabouts and tunnels and the like. And just to finish off,
the road network is a council's most valuable asset. Extending its service life and maintaining good condition helps deliver many of the council's key objectives. Using RHiNOPHALT from ASI Solutions as part of a planned maintenance program can help you get the best from your network. Here's how. Asphalt ages over time, leading to cracking, aggregate loss and potholes. Conventional repair techniques can be noisy and disruptive to the road user, particularly if more than one site visit is required. RHiNOPHALT is a proven asphalt preservative, applied before defects become evident. It penetrates the road surface through microcracks to form a hard seal, preventing water ingress and slowing the aging process, keeping roads in good condition for longer. Installation is quick and quiet, involves a single site visit to minimize carriageway occupation, and can be applied at night. RHiNOPHALT dries quickly to leave a uniform black finish, and road markings can be refreshed in the same shift to further enhance visual appearance. Incorporating RHiNOPHALT into your asset planning will extend the life of your roads and reduce the need for disruptive reactive maintenance. It can also enhance the benefits gained from increased public perception, fewer requests for service, and reduced insurance claims. Contact ASI Solutions today.